When we were finding the prime factorization of numbers and using the prime factorization to find the greatest common divisors and least common multiples of sets of numbers, we encountered the expressions. We used this notation to represent 2 times 2 and 2 times 2 times 2 times 2 times 2, or 2 repeated as a factor 5 times. We now want to study the use of exponents more thoroughly. The vocabulary of exponents includes the word base. The base of an exponential expression is the number being used as a factor some number of times. We use the term exponent. Exponent refers to the number of times that base is used as a factor. So in these examples that we have here, 2 is the base, 2 is an exponent, 2 is a base, 5 is an exponent. The phrase power of a number is another way of specifying the exponent applied to a base. For example, we might say this is representing the third power of 4. To evaluate an exponent then means to carry out the multiplication specified by that exponential notation. So this would be 4 times 4 times 4, which is equal to 16 times 4 equals 64. So if I evaluate the third power of 4, the result is 6. An exponent applies only to the base number to its immediate left. So if I have the expression minus 5 squared, then this refers to the negative of the second power of 5. So this is the negative of 5 times 5, or the negative of 25. If I mean for the exponent to apply to negative 5, then I need to use parentheses. I need to write this as minus 5 to the second power, or minus 5 squared. This then is minus 5 multiplied by minus 5, and we've learned before that the product of two negative numbers is a positive number. So it's important to distinguish between these two expressions and to understand and apply the use of parentheses where necessary to clarify meaning. Now we want to learn some principles for mathematical operations applied to powers. The product of two powers of the same base is the same base with an exponent which is the sum of the exponents of the two factors. So for example, 2 squared times 2 cubed is equal to 2, the same base. The exponent is 2 plus 3, or this then is 2 to the 5th power. This is consistent with what we know to be the meaning of 2 squared. 2 squared is equal to 2 times 2. 2 cubed is equal to 2 times 2 times 2. So when we multiply these two together, we have 2 times 2 multiplied by 2 times 2 times 2. This is 2 used as a factor 5 times, and we write that as 2 to the 5th power. So we get those two results which are consistent with each other. So to restate this, if I want to find products of powers of the same base, I use the same base, and the exponent then will be the sum of the exponents of the two factors. Clearly this would extend to the product of any number of factors of the same base, that is, the product of any number of powers of the same base. The general rule then is written a to the m power multiplied by a to the n power is equal to a to the m plus n power. Now let's consider quotients of powers of the same base. To do that, let's begin with this quotient, 8 divided by 2. This is equal to 4. 8 I can express as 2 cubed. 2 I can write as 2 to the first power, and 4 I can write as 2 squared. If I write this fraction then, or this quotient, using exponential notation, I have 2 cubed divided by 2 to the first power is equal to 2 squared. We can observe from this then that a rule for the quotient of powers of the same base would be that we take the same base and we attach to that an exponent, which is the difference between these exponents. The exponent of the numerator minus the exponent of the denominator. 3 minus 1 is 2. The general rule then for the quotient of powers of the same base is written a to the m power divided by a to the n power is equal to a to the m minus n power. Let's look at another example. 3 to the 4th power divided by 3 squared. If I write these in expanded notation, 3 times 3 times 3 times 3, the denominator Let's look at another example. If I have this quotient, 3 to the 4th power divided by 3 squared, I can write this in expanded notation. This is 3 times 3 times 3 times 3 divided by 3 times 3. I can now cancel these 3's. 1 goes in place of each of those. And now that quotient becomes 3 times 3 divided by 1, or 3 squared. Looking at this in relation to the general rule, a in this case is equal to 3, m is equal to 4, n is equal to 2, and so I have then that 3 to the 4th divided by 3 squared is equal to 3 to the 4 minus 2, or that is equal to 3 squared. Consider this. 2 to the 4th power divided by 2 to the 4th power. Well, we know that a number divided by itself is 1, so we know what that is. Now let's apply the quotient rule for powers of the same base to this. In this case, we had a to the m divided by a to the n is a to the m minus n. Here a is equal to 2, m is equal to 4, n is equal to 4. So applying this rule, we have 2 to the 4th divided by 2 to the 4th is equal to 2 to the 4 minus 4, which is 2 to the 0 power. So it is convenient and accurate here then to define 2 to the 0 power as 1. I should comment here that for this rule, for the quotient of powers of the same base, we must insist that a not be equal to 0. If a is 0, that quotient is not defined. We can infer from this the general rule that a to the 0 power is 1 for any value of a not equal to 0. Now let's consider another case of interest. What would we do with this expression? 5 to the 3rd power divided by 5 to the 5th power. If we apply the rule a to the m power divided by a to the n power is equal to a to the m minus n, we get 5 to the 3rd power divided by 5 to the 5th power is equal to 5 to the minus 2 power. 3 minus 5 is equal to minus 2. What does this mean? Let's look at this quotient by expanding 5 cubed and 5 to the 5th power according to the meaning of those exponents. So we have 5 to the cubed divided by 5 to the 5th power is equal to 5 times 5 times 5 divided by 5 times 5 times 5 times 5 times 5. And now we can apply what we learned in an earlier lesson, dividing numerator and denominator by common divisors. And that leaves us with the products in the numerator 1 times 1 times 1, which is equal to 1. The denominator 5 times 5, or 5 square. So in this example, we can observe that applying the rules for the quotient of powers of the same base, we get 5 to the minus 2. We've shown that that's equal to 1 divided by 5 squared. And the rule is that a to the m is equal to 1 over a to the minus m, or it might be written a to the minus m is equal to 1 divided by a to the m. So if I have a negative exponent in the numerator, I can write the reciprocal of that, changing that exponent to the positive value. Likewise, if I have a negative exponent in the denominator, I can change that by taking the reciprocal of that and changing the sign of the exponent to positive. The last property we will examine is the power rule. The power rule says to raise a power to a power, we raise the base to the power created by multiplying the exponents. That rule is stated this way: a to the m raised to the n power is a to the m times n power. 2 squared raised to the 3rd power is 2 to the 6th. Once again, we can illustrate this by expanding this. 2 squared is 2 times 2. This exponent says we repeat that as a factor 3 times. So we have 2 times 2 and 2 times 2. We might remove the parentheses here and have 2 times 2 times 2 times 2 times 2 times 2, which is equal to 2 to the 6th power. I want to also note here that we may encounter this expression, the quotient of a and b raised to the m power, and sometimes it's convenient to write this as a to the m power divided by b to the m power. Now let's look at another example problem. Minus 1/2 squared, and that quantity raised to the 3rd power. This is equal to minus 1/2 to the 2 times 3 power, or minus 1/2 raised to the 6th power, which is minus 1 to the 6th power divided by 2 to the 6th power. A negative number raised to a positive power is always going to be positive, because if we were to write this as minus 1 times 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 minus 1, we have two sets of products of a negative number times a negative number. A minus 1 times a minus 1 is 1. A minus 1 times a minus 1 is 1. Minus 1 times a minus 1 is 1. And the product of those three positive numbers is, of course, positive number. So that's 1. So minus 1 to the 6th power is equal to 1. You can calculate 2 to the 6th power and find that is 64. So we can write then that minus 1/2 squared raised to the 3rd power is equal to 1/64. Now work the online homework problems assigned for this section on my math lab, and at those sites you'll find additional example problems